designs a biowaste-to-biogas system for Ontario dairy farms. We convert dairy manure into renewable energy using anaerobic digestion, producing a useful heat and electricity while reducing greenhouse gas emissions. Cow dairy farms produce 25 tons of manure per day. Many dairy farms process milk on-site, and that requires a large amount of heat, roughly between 400,000 and 700,000 kilowatt hours per year. Right now, the energy is mostly purchased from outside sources and limited by the Ontario government. At the same time, stored manure naturally releases methane into the atmosphere, a greenhouse gas far more powerful than carbon dioxide. So farms are paying for energy while unused energy escapes into the air. Called anaerobic digestion. We place manure in a sealed tank without oxygen. Inside this tank, naturally occurring microbes will break down the organic material, and as they digest it, they'll produce a biogas which contains methane. That gas is captured and burned in a boiler or combined heat and power unit to generate usable heat for the farm. So instead of buying its own fuel, the farm will produce its own renewable energy source. Tons of manure per day. The system can produce roughly 2,750 kilowatt hours of energy every single day. That heat can power pasteurization, hot water systems, and even keep the digester running. The electricity can power pumps, mixers, or any other electrical needs on the farm. After the gas is removed, the remaining material, called digestate, becomes a nutrient-rich fertilizer that can be returned to the fields. So in this process, nothing is wasted. Cycle assessment shows that this system provides a net climate benefit. On an annual basis, it reduces greenhouse gas emissions by approximately 14 tons of carbon dioxide equivalent. That reduction comes primarily from heat recovery, where biogas replaces natural gas heating. Additional environmental benefits come from exporting electricity to the grid and replacing synthetic fertilizers with nutrient-rich digestate. Instead of emitting methane and relying on fossil fuels, the farm captures energy and closes the nutrient loop. Overall, the system has a net negative carbon footprint, meaning it reduces more emissions than it creates. We already have the raw material needed to produce renewable energy. By converting manure into biogas, we reduce emissions, lower costs, and create a closed-loop system that benefits both farmers and the environment.